Uh, yeah, welcome guys. I'm giving a first talk on .NET Core. Hope not last one. Um, yeah, we are all happy that finally we have Windows containers arrived. They're still raw. We are making a disclaimer. It's still super raw to use in production, but already in development and in continuous integration, you can start using them, testing them to get used. When they will be more mature, you will be able to use them in production. Can you raise your hands who already been working with Windows containers? Awesome. Who was working with Docker containers? Okay. Thank you guys, because this talk is really oriented for beginners. So yeah, I don't need to say that you can go out and wait till next one. Yeah, we'll talk today mainly the basics of Windows containers. And yeah, I would like to start with ASP.NET application structure. So what's the typical structure of the ASP.NET infrastructure? When you deploy your application, usually you have hardware, operating system, .NET platform, IIS, and user content. Whenever you deploy the application, you would like to be able to manage CPU, RAM, and disk space of your website. Also, you would like to be able to manage processes, I/O, network, and permissions, which are really tricky for ASP.NET, as you know. Also, you want to manage the version of framework, you want to know how it gets compiled, and you want to get how it runs, because we have all the profiles and we have all the batch of settings for IIS, which is also tricky, and ASP.NET is not the easiest way to run your application. Yeah, on IIS level, you would like to be able to manage all the settings for IIS, for your application pool, and for your website. And usually you would like to have really customized settings even on the IIS level for different websites. And last but not least, you would like to see all the third-party dependencies. You would like to be able to manage your binaries which you're deploying. And in our case, what we're usually using is for hardware and operating system management, we're using virtual machines. For provisioning, for .NET Platform and IIS to set up the machine on top of the operating system, we're using provisioning. And for delivery, we're using continuous integration and continuous delivery. But what if we would like to put all those three things into one box, make it really immutable, and have one single state? Well, in result, we will get a container. So that's basically what is the container. The container is an image of certain state of the system. Yeah, right now, finally, we are able to use Docker containers on the Windows, which I think is really, really cool. So what are the benefits of the containers? First of all, containers are isolated. So basically, each container has a separate environment, and they are not contacting between each other if you are not allowing them to contact. Also, they're isolated from the host system, so it's really hard to impact the host system from the container. And with default settings, you cannot do this, actually. You have full resource control, so basically you can control amount of CPU which container you use. You can control RAM which used by container. You can control disk space, and you can control how it's used by the container. Also, because of containers are immutable, you have the full portability. It's super easy to move container around. It's not attached to any kind of system. You just need to have Windows installed, container feature enabled, and you have it. So basically, you can move one container from one developer machine to another or to production, and it will work exactly the same on each machine. So no more pain with the setting up, opening ports, etc., etc. It just works. Yeah, let's start with container fundamentals. I will show all the parts which are needed to know before Paul will give his talk more practical. So what is the client? basically client of Docker in Windows represented by Docker .exe. It's executable file. It's basically a command line for your Docker host. From this command line, you are able to send commands to the host machine, or if it's the same machine, you can control exactly the machine, control the flow of containers, how they work, how they persist, etc. Okay, what is the host? Host is basically a physical or virtual machine with Windows containers feature enabled and Docker service running. What is image? Basically, image is something similar to virtual machine images, which are usually called ISO. Here, it's basically a template from which your container will be built. It's like a bunch of layers built it one on top of the another, which use a union file system. So basically, it's really different versions of layers built it on top one of another. And the cool thing that you can see that the size of images goes smaller and smaller from bottom to top. And basically, when you need to change any part, it's just replacing exactly this part. So in our case, for example, we have a container with our application, and we decide that, okay, we want to upgrade ASP.NET on all our servers. We're just replacing this container, and only 400 megabytes will be transferred. So we don't need to transfer the huge image. As you can notice, it's 8 gigs, the whole system. We don't need to transfer it anymore. And the same for our continuous integration. When we need to deploy new source code, it just exchanges the one layer. So the idea is that image is really immutable structure, but you can replace each level and you will get the new image afterwards. Okay, how to build image. Docker provides a manifest file called Docker file, in which one you can basically set on which image you would like to base your current image. You can add some things into image, for example, scripts or source code or whatever you need, all resources. You can set up working directory, you can set up environment variables. Important thing, you can run whatever you want in the container to prepare, while it's building, to prepare the container as it should be. In our case, for example, we are running PowerShell and we are installing packages. So this is a part of the container which we are using internally. And as a result, we can say what is the entry point. So what will be started when container spins. In our case, we will run system monitor just to show the debug information of the service. What is container? We know already that image is just a template. Container is an instance of the image. You can have multiple containers from the same image. All of them are isolated, all of them are not connected, and all of them are based on the same image. Or you can easily replace one layer of one image of one container, and you will have different containers as well. What is registry? In Microsoft, for some reason, they're calling it repository. I don't know, because maybe for team server people, it's much easier to call it repository, but officially it's called registry. Registry is basically a repository where you store your images. One of the repos called Docker Hub, it's official registry, where all the vendors are storing their official images, so you can pull image official version of Windows Server, for example, or .NET Core, or .NET, or Node, whatever. But this is not only one. So you can easily spin your own registry as a container as well. And you can store your own images there. So for example, we are storing our Lodgify builds as a separate images in the registry, in the local registry. This is done on purpose because we don't want to share these containers with the whole world. Sorry, it's too wide. This is basically the scheme how registry works. From your Docker client, in my case it's laptop, when I'm going to the server, to the Docker host, and I'm trying to run container, in our case, for example, it's Redis, we are checking that locally we have already the layer with Ubuntu, and we are starting to build our container. But also we don't have the last layer which contains Redis. So it goes to registry, the official one and downloads the image. And then it's able to build those two images because of their contains, they are built one on top of another, and create a container. Next time when you want to run another container with Redis, it will be run directly from local machine because you already have the image. It's cool, but what if you would like to spin more than one container? Then you need to run each one manually, then there is a pain to connect them, etc. So guys from Docker proposed a tool called Compose. It's basically another manifest file, which allows you to build the architecture of your infrastructure. You're just saying how many and which services do you have. In our case, for example, we have 2 MS SQL, 3 Lodgify backends, and 1 Nginx, which is the front end. And all of them are connected together, but not connected to anything else. So they're like a bounded thing, and it's like really isolated. To create it, you can use another YAML file, which is also a Docker Compose manifest. And you can declare your containers. You can specify which image it is, which ports it should expose to this network, which networks do you have. Right now, Windows supports only one, which is not. Still pretty buggy, but yeah, you already can use it. It's not that isolated because you can access it through your machine, etc. But yeah, at least something. And also you can say the dependencies. So basically, when you spinning up one container, you're saying that it needs to wait to another container to start. So you are ensuring that your database start before your backend, and your backend start before your frontend. So your frontend doesn't throw errors because backend is still trying to get it run. What about Windows containers? So mainly things that I've already explained, they're applying to both Windows and Linux containers with small differences, but more or less it's the same. In Windows world, from some reason, they have created 2 types of containers. One is called Windows Server containers. One is called Hyper-V containers. Basically, what is a Windows Server container? On the host machine, you are running kernel, which is the biggest part of the system, and it's shared between the host user mode. It's basically your session with your system processes. It's like your operating system, and Windows containers itself. Each container runs its own system processes and application processes. Here is the big difference, because in Linux, containers are much smaller and they are running only the application service. So they are sharing much more things with the kernel, with Linux kernel. Unfortunately, in Windows, you still need to run a bunch of system processes, magic ones, who don't, like, nobody knows what they are doing, but they are there. Yeah, and you can have multiple containers on one host. All of them will share the same Windows kernel. That gives a performance boost comparing to virtual machines, because actually you can share one kernel and share all the resources without building the virtual machines on top, which consumes the power of the machine itself. There is another type called Hyper-V containers, and just today we decided not to show it to you because it's super crazy, the architecture part. I don't want to blow your mind, and I still would like you to try this, because if you will see how it works, you will just say, no, I don't want. Yeah, so let's start small demo. I will show basic introductions, basics, so I will prepare you and you will understand more or less what Pau will do. Okay, here what I have, sorry, here I have Azure machine running Windows Server 2016, finally release version. And yes, containers are working here, because from all of you who already tried Technical Preview 5, containers was working 50% chance. So right now it's fixed. It's more or less working, I hope. Yeah. So I will launch console. Oh, sorry. I will launch PowerShell because it's cooler. And so basically, yeah, we will start with the simplest command called docker images. It shows us all the images that we have. I'm sorry, guys, do you see it well? It's okay? The most important part is here. So basically, we have 2 types of containers. First, is a Windows Server core. It's like a Windows Server, the big, powerful machine, but cut it a lot. Guys from Microsoft made a good job. They have removed a lot of things, including a fax server, the joke which I like the most. Yeah, so you can see still it's already not 30 gigs as the usual operating system, but it's like 9, around 9. And they have also created a thing called Nano Server, which is like a super light version of Windows. Right now it supports only Windows Core. They're working hard to make run .NET on there, like the regular one. It's still super hard, and they are quite big for now. For just comparison, I will show you. Here is my Mac machine, and I'm running Docker for Mac here, and I will show you the same here. So let's check Redis image size. 100 megs, like 200 megs here. Let's pull Docker, pull Alpine, which you know is one of the smallest images. And let's check the size of Alpine. 4 megabytes. That's just a small comparison. So yeah, but they are really improved because from the beginning it was like almost 15. So it was the whole image there. Yeah, let's start with a small thing. To start, basically we have images already. We will not create images because it's kind of long part and Pau will do this. We'll just run one of the images. I would like to run it in interactive mode. So I'm adding -it, and then I can specify the name of the image, --name, we'll call it test. And then I'm specifying the name of the image. Microsoft. Yeah, as you can notice, big thanks to Microsoft for really short names. Like it takes about 2 minutes just to type, and then there are a million of typos. Compare Alpine or Nginx to Microsoft Server Core. Oh, sorry, need to cancel. I've started it without the command. Sorry, Docker -it. Then the last parameter is which process we would like to run.
You are inside the image.
I'm already in the image. Yay! So yeah, sorry, we're already in the image. I thought that I've pressed exit. I thought it was exiting. Yeah, so we're inside the image. We can see all the cool stuff here. It's smaller than regular one. Basically, yeah, it's Windows. It's headless, but you can still use it. You can run a bunch of cool stuff, but yeah, I will show one more thing.
Now you are back.
Huh?
Now you are back.
Yeah, I can see it. Yeah, here I have, sorry again for too wide screen. I have a website which is not running because I would like to run it in the container. So basically I will run the container here, docker run -d. It stands for detached, so we would like to run it in the background mode, not going inside the container. Then I'm specifying -p. I'm saying which ports I want to connect from my host to the container, so which ports I want to expose. I will give a name called IIS. Oh, sorry. And I will give, man, it's so hard. At least this one is shorter. So yeah, we can spin it up and we can see that it was not found locally because I didn't have the image. So it's pulling it from the official repository. Still there is, I guess, a bug or something because it takes super long time to fetch the image because they're doing crazy things under hood. But it's only for Docker for Windows. On Linux, it works much faster. So yeah, let's wait for a second. No. Yay! At the bottom, it shows up the ID of the container, pretty long. So to prove it, we have an IIS running in the container. What we else could do, we can say docker ps to see all the containers running right now. So here we have our guy up and running. We can say docker stop, so we can stop image. We have a name called IIS, so we can stop. We can remove it, docker rm IIS. We have removed it. To prove it, we can make docker ps again to see that there is no containers. And docker images, we see that we have a bunch of images. And the cool thing actually that IIS image is based on top of Windows Server Core. So you can see here the size, the difference, it's like 300 megabytes. It's the IIS part. So basically, if you will pull another container, it will pull only the difference. So in our case, it was pulling only 300 megabytes, not 8 gigs. And to remove container, we can, oops, sorry. To remove image, we can say docker rmi. Oh, sorry. So yeah, basically it removed all the parts, and if we will make docker images, we can see that image is gone, but the base part is still there. Yeah, so from my side, it's basically that's all. And I will switch to the presentation. Useful things, I will share the presentation. Basically, those are two crazy guys from Microsoft, principal leads and architects, which are speaking about things under the hood. So if you would like to know about this second type of container, definitely watch it. Then there is a cool video of how to deploy containers. It's basically about the infrastructure, how you can prepare it, how you can set up a continuous integration, continuous delivery for containers. And there is another link, which is apparently the new service from Microsoft, Microsoft IT Pro Cloud, where you can register for free without credit card and get 3 months, $100 per month from Azure for testing. They're giving credits for free just to test it. That's all. Thank you guys. If you have any questions.